Okay, geometry. Last time we took a look at central angles and arc measure and saw how those two concepts were very closely linked together. Today we are going to expand on that and we're going to say if we've got an arc with a measure of however many degrees in a circle with a radius or diameter of some length, then how long is that arc? How far do we have to actually travel to walk around that arc? And for that, we're going to use a formula for arc length. Okay, so you do have a formula for this. It's on, I believe it's page 2 of your note packet, the back side of the front page down at the bottom, where we've got arc length is equal to x times c over 360. Now, x is the degree measure of the arc that we figured out last time, and c is the circumference of the circle. But what I'd like to look at real quickly is where does this formula come from? And to do that, I'm going to come over here and we're going to look at a ratio. So we're going to set up a little bit of a ratio where we're going to show, or we're going to set up a proportion where we show that two ratios are equal to each other. Because the arc measure and the central angle have the same degree measure, we can say that x over 360 is equal to, okay, so let's take a look at that ratio real quick. Our x is our central angle measure, which is also the degree measure of the arc. And it is some proportion, or it's some part of 360. We know that we can go 360 degrees and we'll get around the entire circle. So our x, it's some part of that. We don't know how much. I mean, we do if we put in an actual number for x, but it's just some part. But the thing is, it's going to be the same part of that as the length of our arc over the circumference. So these two fractions are equivalent. Our arc measure over 360 degrees is equal to our arc length divided by the circumference of the circle. So to get our arc measurement or our arc length formula here, all we need to do is multiply both sides of this by c. That cancels the denominator here and puts the c up in the numerator on the other side. So we get that length is equal to x times c over 360. So keep that in mind, keep that formula handy, and this shouldn't go too badly for you. The only thing we have to do is make sure we can find the circumference okay. And on a lot of these, we are going to just be rounding. So let's look at number 1. So in number 1 here, we've got a radius of 6 meters, which means that our circumference is going to be 2 times pi times 6. So our circumference is equal to 12 pi. Okay, our arc measure here is 107 degrees. So that means if we want to find the arc length, what we can do is say that the length is equal to the measure, so 107 times the circumference, 12 pi, and then we're going to divide that by 360. Okay, and from here we can just punch this into the calculator. So I'm going to do that. Can't see it on the video, I know, but I'm going to punch that in real quick, and we're going to get 107 times 12 pi divided by 360. If you're using a scientific or a graphing calculator, you can just put that all in on one line, and we get about 11.21. And this is a distance, just a linear distance. So that's 11.21 meters. Okay, let's do one more of these, and then maybe we'll look at an application type problem down below. So on number 2 here, we have a circle with a radius of 15 inches, and we need to know the circumference of that if we want to find the arc length. So our circumference is 2 times pi times that radius of 15. So our circumference is equal to 30 pi. Our arc measure is equivalent to this central angle here of 38 degrees. So that means that our arc length is equal to 38 times 30 pi, and that's going to be divided by 360 degrees. Okay, and then punching this in the calculator, again, if you're using a scientific or a graphing calculator, you can just throw this all in on one line. And we get that this is 9.95, and we are in inches this time. So that's just the quick and honestly pretty simple way to find that arc length. So let's go down below and let's look at an application type problem. Okay, so on number 11 here, we've got a 16-inch pendulum swings through an angle of 40 degrees. And we want to know how far does the tip of the pendulum travel in a single swing. So what we need to do is we need to draw a picture. So what we're going to have here is, let's see. Let's start with just like a central point, maybe right here. And then we've got this pendulum that is 16 inches. We'll call that 16 inches right there. And it's swinging from this far point over here and then through about 40 degrees. So that would be maybe something like this over here. So we have created this pendulum here, and it's going through this arc. So it's going to swing something like this. And we've got this 40-degree angle and a 16-inch pendulum. So let's get those in there. So 16 inches and 40 degrees. Now, even though we don't have the entire circle, we can imagine that if we were to just, grab this pendulum and start swinging around our head or something, it would make a circular motion. So we can use the arc length formula here to figure out if we take the pendulum right here and we drop it off and it swings the other way all the way to over here, how far does the tip of that pendulum swing? Okay, so let's use the arc length formula. But first we need to find the circumference of our imaginary circle if we were to, again, just take that pendulum and swing it around our head. So with a radius of 16 inches, that means that our circumference is 2 times pi times 16, which is equal to 32 pi, and that is in inches. And that means that our arc length is equal to 40 times 32 pi, and that's going to be divided by 360. And from here, we can just punch this into the calculator. So 40 times 32 pi divided by 360 is equal to 11.17. And this is in inches. So if we were to pull our pendulum over here and let it go, it would swing a little bit more than 11 inches to get over to this part before it started to swing back. Okay, so that's going to be everything about arc length for this video. Make sure to bring questions if you have any, and I'll see you in class.